Opening crisis. The miracle fails. March 1944, 15,000 feet above the English countryside, Captain Francis Gabreski clutched the controls of his P-47 Thunderbolt. The air was thin, the sky a patchwork of clouds beneath him, and his engine, the one that was supposed to make his plane a game-changer, suddenly betrayed him. The power he had counted on, the very thing that would allow him to chase down the Luftwaffe and gain air superiority, was failing. The engine coughed, sputtered, and lost power. Gabreski's heart raced as his gauges flickered, indicating a loss of manifold pressure. His throttle, normally a commanding lever, now felt useless. The American engineers had promised that the new water alcohol injection system would give his Thunderbolt an edge, an extra 30% power. The system was supposed to elevate his aircraft's performance, pushing the engine beyond its normal limits, giving him an advantage over the German fighters that dominated the skies. Instead, the engine began to sputter and die, and Gabreski realized with dread that his miracle system had become a nightmare. He glanced at his wingman, Lieutenant Bob Johnson, who was also struggling to maintain altitude. The two pilots had been part of a critical mission, and now they were limping back to base, unable to help their squadron. The Germans had gained the advantage, just as the engineers had promised a solution. The fuel system had failed them. They were down to half power, and every mile closer to the base felt like a victory in itself. As Gabreski fought to maintain control of his aircraft, he knew that the U.S. Army Air Forces were in deep trouble. The system they had hoped would provide a decisive edge was instead undermining their efforts in combat. The water alcohol mixture that was supposed to help the Thunderbolt reach speeds beyond the capabilities of enemy planes had instead become the very thing that endangered their pilots' lives. Backstory: Frank Walker's vision. Frank Walker sat at his desk at Hamilton Standard Propeller Corporation in East Hartford, Connecticut, surrounded by papers, charts, and his latest test results. Walker was an engineer by trade, a man of precision and methodical reasoning. At 30, he had already earned a reputation as a genius in mechanical design. But even he had to admit his latest project felt like a gamble. The U.S. Army Air Forces were locked in a fierce aerial battle in Europe. American planes, including the formidable P-47 Thunderbolt, were struggling to keep pace with the German fighters. American aircraft were reliable, but they lacked the raw speed and agility of their enemies. The solution seemed clear: more power. With a stronger engine and better fuel, the Thunderbolt could surpass the German fighters. Walker had been working on a new fuel system that would do just that. The concept was simple: a water alcohol injection system that would push the engine beyond its normal limitations. This system would increase power, improve fuel efficiency, and allow American aircraft to outclimb and outrun their German counterparts. The initial tests were promising, at least until the system failed in the field. The engineers at Hamilton Standard had faced significant resistance. Everyone from military officials to fellow engineers were skeptical of Walker's idea. They argued that such a system was too complex, too prone to failure. They had believed that the laws of physics could only stretch so far before the results were catastrophic. But Walker's numbers told a different story. His calculations were clear. With the right fuel mixture, the American fighters could achieve the kind of power that had once seemed unattainable. His confidence, however, was not shared by others. Despite the skepticism, Walker pressed forward. His breakthrough came when he discovered that the standard fuel mixtures being used in the military were causing engine knock, a phenomenon where the engine would detonate internally, due to excessive pressure. Walker's data suggested that a different alcohol mixture, one that had been dismissed by experts, might provide the solution. It was the kind of idea that could either change the course of the war or destroy Walker's career. There was no middle ground. The problem: the limits of conventional wisdom. The problem American engineers were facing was multifaceted. The aircraft they had were good, reliable, well-built, and capable, but they lacked the performance edge needed to turn the tide of the war. While the Germans were flying aircraft that could outmaneuver and outrun the American fighters, the U.S. had to make do with what they had. The answer, they believed, was to improve the power of their existing engines. The idea of modifying fuel systems was not new. The German Luftwaffe had been using complex fuel mixtures to extract more power from their engines for years. The Allies, however, were caught up in traditional engineering principles. The belief was that there was a limit to how much power an air-cooled engine could generate without catastrophic consequences. Engines that pushed beyond their rated limits would fail under stress. The laws of physics were clear on this point. Any attempt to go beyond these limits would result in mechanical failure, especially in the high-stress conditions of aerial combat. Frank Walker had seen this problem firsthand. He had worked on several projects where engineers had tried to push engine performance, only to see their designs fail. But he had also seen where others had failed, and where their assumptions about the limits of engineering were wrong. What if, he thought, the limits could be stretched? What if, instead of pushing the engine itself beyond its limits, they could modify the fuel to achieve the necessary power boost? Discovery: the impossible fuel mix. Frank Walker's breakthrough came when he looked beyond conventional wisdom. For years, the military had used a specific fuel mixture, one that was considered safe and reliable. It was the go-to solution, and it was the one that was used in the P-47 Thunderbolt. But it wasn't enough. As Walker analyzed the data, he realized that the existing fuel mixture was actually causing the very problems it was supposed to solve. The standard fuel mixture caused engine knock at high power levels, a phenomenon where excessive pressure would cause the engine to detonate prematurely. This limited the engine's ability to operate at peak efficiency, especially in combat situations where every extra ounce of power mattered. Walker's calculations suggested that by replacing the alcohol in the fuel mix with a higher octane formula, the engine would be able to operate at higher pressures without failing. At first, his suggestion was dismissed as impractical. The engineers at Hamilton Standard were wary of anything that wasn't already part of the standard protocol. But Walker was persistent. He argued that the fuel system could be modified to unlock more power without compromising reliability. It would be a gamble, but it was the only way to give the American fighters the edge they needed. Walker's formula was based on using a mixture of water and isopropyl alcohol. The water would cool the engine, while the alcohol would boost its performance. It was a simple solution, but one that seemed to defy the conventional rules of engine performance. To the experts, it sounded like a risky experiment. To Walker, it was the answer he had been looking for. First success: the test flight. The test flight was the moment of truth. Frank Walker's new fuel mixture was poured into the tank of a P-47 Thunderbolt, and the aircraft was sent into the air. The stakes were high. If the fuel system worked as planned, it would provide the U.S. with a huge advantage over the Germans. If it failed, it could ruin Walker's career and the hopes of a generation of American pilots. The results were astonishing. The aircraft's engine roared to life, delivering more power than it ever had before. The Thunderbolt's climb rate improved dramatically, and its speed increased by over 100 miles per hour. The new fuel system was exactly what Walker had promised: reliable, efficient, and incredibly powerful. For the first time in the war, the American fighters had the edge. The new fuel mixture had unlocked the kind of power that was previously thought to be unattainable. The P-47, once seen as an underdog in the sky, was now a formidable adversary capable of taking on the best that the Germans had to offer. Escalation. The challenge grows. While the success of the new fuel mixture was promising, the true test came when it was put into combat conditions. The P-47 Thunderbolt, now armed with Walker's innovation, was sent on several missions over Europe. Each mission tested the limits of the aircraft's performance, and each mission revealed new challenges. The fuel mixture worked well under ideal conditions, but combat was anything but ideal. Extreme temperatures, high altitudes, and the constant pressure of battle meant that the system would have to work in the harshest conditions imaginable. But Walker's fuel mixture continued to perform, even as the military engineers tried to break it. Cliffhanger. The final test. The final test came when the P-47 Thunderbolts were sent on a critical bombing run over Germany. The mission was high risk, and the stakes were higher than ever. As the American fighters neared their target, the pressure was on. Would the fuel mixture hold up under the intense demands of combat? As the engines roared and the bombs dropped, the fate of the mission and the future of the war rested on Frank Walker's impossible fuel mix. Would it work, or would it fail at the most critical moment? Action resumes. The war continues. The war raged on. The success of Frank Walker's fuel mix had provided the United States with a much-needed edge in the skies, but the true test was only just beginning. American fighter pilots now had the power to fight back against the Germans, but with every mission, the risks grew higher. The engine that had been saved from failure by Walker's innovation now faced new challenges in combat. Captain Gabreski's P-47 Thunderbolt, which had limped back to base in the previous chapter, was one of the first to be fitted with Walker's fuel system. He had been skeptical, but after the engine failure, there was no choice but to try something new. Gabreski had now flown with the new fuel mixture several times, and though the system seemed to work, there was always a nagging fear at the back of his mind. What if it failed again? On his next sortie, Gabreski and his squadron of Thunderbolts climbed into the sky, ready for action. The sky was their battleground, and the fuel system would be tested once more. The mission was a high-stakes raid over German-occupied France. The target was a heavily defended industrial complex, and the enemy was well prepared. Gabreski's fighter roared through the air, the new fuel mixture humming in the engine. The Thunderbolt's climb rate had improved significantly, and the aircraft felt more responsive than ever before. As Gabreski engaged the enemy fighters, he felt the power of the engine pushing him forward, giving him the confidence he needed to press the attack. But as the battle raged, Gabreski's heart sank. The engine began to sputter. Not again. The same problem that had nearly cost him his life on the earlier mission resurfaced. The fuel system was failing, and Gabreski had no idea why. Multiple episodes. A solution in the midst of chaos. Over the next few weeks, Walker's fuel mixture was tested in combat again and again. Every time the results were the same. When the system worked, it was a game changer. The planes soared through the skies at unprecedented speeds, leaving their German counterparts trailing in the dust. But when it failed, the results were catastrophic. Pilots were now flying under constant stress, wondering whether their fuel system would hold up. They knew that a failed engine could mean the difference between life and death. The problem was clear. The fuel mixture was not working consistently in every situation. Something in the system was causing failures at random intervals, and the military engineers were scrambling to figure out why. Walker was brought in to troubleshoot. He worked with a team of engineers to isolate the issue. The system had worked perfectly in the controlled tests, but in the chaos of combat, there were too many variables. Walker realized that the fuel system needed to be recalibrated to account for the extreme conditions of aerial combat. Temperature, altitude, and engine stress all played a role in how the fuel reacted inside the engine. The mixture needed to be adjusted in real time to maintain optimal performance. But this solution was not as simple as it seemed. The complexity of the task grew as the engineers discovered new issues. The fuel mixture, while powerful, had side effects that nobody had anticipated. High-altitude missions caused the fuel to freeze, rendering the system useless at the most critical times. The more Walker worked, the more he realized that his invention had only scratched the surface of what was possible. But he was determined not to let it fail. Enemy response. The German counterattack. As American fighters began to gain the upper hand in the skies, the Germans adapted quickly. The Luftwaffe, never one to sit idly by while the enemy gained an advantage, began to develop countermeasures. German engineers had long been working on improving their own fighter planes, and now they were forced to accelerate their efforts in response to the American breakthroughs. The Germans were aware of the American fuel mix, and they quickly began developing ways to neutralize it. They tested new tactics, designed new weapons, and honed their technology in preparation for the next phase of the war. In particular, the Germans focused on counteracting the speed and maneuverability of the American fighters. The impact of these changes was immediate. German fighter pilots, already some of the best in the world, now had access to faster, more agile planes equipped with weapons designed to target American weaknesses. They had noticed that American pilots, while superior in many areas, often struggled with handling their aircraft at high speeds. The Germans had been working on improving their own fuel systems, hoping to match or exceed the Americans' new advantage. On the front lines, the American pilots began to feel the pressure. Their superiority in the air, once a source of confidence, was now under threat. Gabreski and his squadron found themselves facing an enemy that was adapting faster than they had anticipated. The new fuel system, which had given them such an edge, was no longer a guaranteed ticket to victory. The Americans needed something more, something beyond just a fuel mix. Consequences. The weight of success. As the war progressed, the impact of Walker's fuel system was felt across the entire Allied campaign. The American fighter planes were performing better than ever, and victories in the air began to mount. But with success came new challenges. The increased power in the engines led to greater stress on the aircraft. Walker's fuel mixture, while providing a significant power boost, also placed additional strain on the mechanical systems of the planes. The engines were now working harder than ever, and the wear and tear on the planes was noticeable. Walker had solved one problem, but in doing so, he had created new ones. The military was forced to balance the need for power with the reality of maintenance and mechanical failure. Aircraft that had once been reliable and sturdy were now requiring more frequent repairs. The increased power from the fuel system came at a cost. Longer maintenance hours, more replacement parts, and increased risk of mechanical failure mid-flight. Impact. a new age of aerial warfare. Despite the setbacks, Frank Walker's fuel system had achieved what many thought impossible. The American fighters, now equipped with this revolutionary technology, had gained a significant edge in the air. The U.S. Army Air Forces were able to outmaneuver, outrun, and outgun the German Luftwaffe in a way that had once seemed like an unattainable dream. The new fuel system was credited with improving the performance of American fighters across every flight regime. Takeoff distances were reduced, climb rates increased, and service ceilings reached new heights. The power boost enabled American fighters to engage the enemy with more confidence and fewer limitations. But perhaps the most significant impact was the psychological effect it had on both the American and German forces. The German pilots, who had once considered themselves superior in the air, now found themselves struggling to keep up with their American counterparts. The Allies, on the other hand, gained new confidence in their ability to dominate the skies. The success of the fuel system was not just a technical victory. It was a victory of American ingenuity over adversity. It showed that even in the most dire circumstances, innovation could change the course of history. Post-war reflection: the legacy of Frank Walker. After the war, Frank Walker was celebrated as one of the unsung heroes of the American military effort. His innovation had played a pivotal role in achieving victory in the skies. But he remained a humble engineer, more focused on the mechanics than the accolades. Walker's fuel system became standard issue in American fighter planes, and its principles were applied to future aviation technologies. The lessons learned from his invention shaped the design of post-war military aircraft and influenced civilian aviation as well. But Walker's legacy was not without its complications. His fuel system had been a gamble, one that had paid off in unexpected ways. But it also highlighted the inherent dangers of pushing technology to its limits without fully understanding the consequences. For every victory, there was a cost. For every advantage, there was a risk. In the years that followed, Walker's name was often mentioned alongside the great innovators of the war, those whose ideas had changed the course of history. But even as he received the recognition he deserved, he knew that the true impact of his work was not just in the power of the engines he had helped create, but in the lives that had been saved as a result. Legacy: how one engineer changed history. Frank Walker's fuel system changed the way aerial combat was fought. The American fighters that had once been underpowered and outmatched were now superior in the sky. The fuel system unlocked new levels of performance, giving the U.S. an edge in every combat situation. More importantly, Walker's innovation became a symbol of American ingenuity. In a world at war, where technology often seemed to be advancing beyond human control, Walker showed that a simple idea could make all the difference. His legacy lived on in the aircraft that carried his fuel system, in the engineers who followed in his footsteps, and in the pilots who flew with newfound confidence. The lessons learned from his work were applied in the years after the war, and his contributions to aviation technology would shape the future of flight. Frank Walker had defied the odds, and in doing so, he had helped win the war. And while his name may not have been as famous as the generals and pilots who fought in the sky, his impact on the war effort and on history was undeniable. If you enjoyed this untold story of ingenuity and innovation, make sure to subscribe to the channel and hit the notification bell so you don't miss out on future episodes. New videos come out daily, bringing you more incredible stories from history. Share your thoughts in the comments and let me know where you're watching from.